Thanks very much, Mitchell. That's all good. Lovely to see a new member here. Fantastic. Yep. And just a happy birthday to a good friend of mine, Chloe, whose birthday today. I said I'd say happy birthday online. Happy birthday. I think, are we recording?
Yeah.
Yep. Good. So let's drop the lights down.
Yes, I can do that.
Yeah, that's nice and low. Can we drop those ones? Yeah, that's good. That's good. Yeah, perfect. Perfect. Thank you very much. Thanks, guys, for coming out. So I'm going to start tonight's talk with a video of the historic first manned landing in July 1969. It's only about a minute long, but it's broken up into three sections. The first brief section is one taken, the camera's inside the lunar module, looking through the window outside as it's coming into land. The image is pretty grainy, it's got a lot of dust flying around it, it's old film. But you'll see there, as it comes in, you'll see the shadow of the lander, and you'll see the shadow also of a probe going down from one of the legs of the lander. And you'll hear, as it touches the ground, it sends a signal called a little light in the lunar module called contact light, and it goes on in the cockpit. And you'll hear Neil Armstrong saying, contact light, engine stop, because as soon as that sensor touches the surface, they shut the engines down, so they free fall the last few feet, because they don't want dust and debris flying up into their engine bell. The next section is when Neil Armstrong's going down the ladder, and he's got a little lever to one side, and he pulls on it, and it releases a camera, and that films him coming down the ladder. And then the third shot is from inside the lunar module again, looking down at Neil Armstrong, taking those first few steps. And they're just, some of those are views that you don't normally see. So let's just start with this video. We're just checking how the sound's going too. No. How's that sound, Derek? Nope. No sound. I've got my Bose here if need be.
What's your audio output like?
I should have checked this before. Here we are. No, something's not right. No sound.
Are you outputting through the HDMI?
Yep. I should have checked it before. In fact, I've lost the screen now too. I've just.
I can disconnect it. You should lose it.
Sorry, guys.
I'm still getting captures.
I've
you
got
want
nothing.
to restart the presentation? Yeah, because you got out of the presentation mode. This is no longer in presentation mode. Where's your mouse?
So what happened to sound?
Should be back. Is the video meant to go on?
Good? Audio.
No.
So what's happened to the audio? Because I got about 6 videos in here this evening. So
Use the Bose.
No. Oh. Yeah, it's finicky, this one. Okay.
why don't I just use the Bose?
Use the Bose.
Yeah, probably easier.
Okay. Luckily I bought this for backup. Because we've got about 6 videos.
100%. Connected to. Not withdraw.
Okay.
Is it connected?
Yes, it is. Yeah.
We'll just check.
Yeah, it is.
Okay, cool. Then
Okay.
We'll just
Go back to here.
And then, well, yeah.
Yes, we're still recording all this, didn't you? You got my
Play from
birthday
current-
recording, didn't you? You got that on recording? Yes? Yeah? You got the birthday message on recording? That was recorded?
Not that one.
Oh, when I said happy birthday?
No, that was after that one.
Oh, you didn't start recording till after that. Should we start again?
Oh, really? Okay. Well, now it is streaming now, so whatever you say will be out there.
Okay. So the first bit didn't get recorded? No. Oh,
I
okay.
usually don't record announcements, so
Okay.
you can give another shout out.
No, that's fine. Okay, let's get underway. So thanks, guys. So let's get underway again. That was the video, and my shout-out didn't get recorded. So happy birthday, Chloe. There you go, got recorded. Okay, let's move on. So I've explained the video, what we're going to see. So let's see how we go from here. I need to volume switch. How's that? There you go, very historic. So Neil, of course, is your crew. Neil Armstrong, the commander. Buzz Aldrin, lunar module pilot, on the right there, who these two walked on the moon, and Mike Collins, the command module pilot, who stayed in lunar orbit in the command module, keeping an eye on things. And of course, this very iconic image here of Buzz Aldrin on the moon. So who here recalls seeing that and getting excited by it? You know, yeah. Almost every hand in the room goes up. But 5 further successful landings followed. Who, for example, could just state, 1 or 2 interesting facts about each of those missions? Yeah, 1 or 2 hands goes up, which is great, but the number of hands in any group of people is significantly much lower. And that's why tonight's talk is titled The Apollo Moon Landings, The Lost Missions, where I'm going to give an overview of all 6 landings. We're going to talk about the people, the technology, and the science. And I will show you how with each mission, the scientific and technological advances were significantly high each time they went. By the end of those missions, Neil and Buzz would have had their tongues on the floor drooling at what these other guys were up to on the lunar surface. So I've split it into these 3 chapters. We're going to look at the successful landings, the science on the moon, and what the landing sites look like today. So getting part 1, we're going to talk about each mission with some of the stories. We're going to look at some images. I've got some popular images, but I've also tried going for some less common images, some panoramic views. NASA's increased the resolution, digitally enhanced a lot of the pictures, and then stitched them some together to create some nice panoramic views. And then we're going to have a few videos sprinkled in there as well. So there's, of course, the picture that we saw earlier of the crew. The objective of Apollo 11 was just land on the moon, prove that you can do it, get some samples, do some science, and get out of there safely and get back home in one piece. That was their prime mission. Keep this in mind. They did 1 moonwalk, which was 2.5 hours roughly, and they ventured 90 meters from the lunar module. So just keep that in mind as we go through each mission. I'll be reminding you anyway. So 1 moonwalk was 2.5 hours, 90 minutes ventured from the lunar module. And the other one is they returned 22 kilograms of samples. It's another fact, just to be mindful of as we go along. So this is that iconic image that we saw before. And a couple of features in here, just absolutely love this. The first up, you'll see Neil taking the picture. That's the reflection of him in Buzz Aldrin's visor. You see him there. And the other one is, we talked about those probes. There's some other pictures later showing that, but that's some of the, there's the foot pad of one of the legs of the lander, and that's one of the probes that's obviously being buckled as it landed. So it was when one of those touched the surface, the little sensor said contact light. So this is an image of Buzz descending the ladder down into the lunar surface. He came down 19 minutes after Neil. And I put that in there because the pictures of Neil coming down are all black and white and grainy. And of course, you can't see that's the scene because it's taken from inside the lunar module. But I took this image because that's what, if you were on the surface, just hypothetically, that's what Neil would have been experiencing, what it looked like coming down the ladder. And this is the landscape, the view that he would have seen. So I find that picture just draws you in. So you realise you get a better feeling what it was like. So this is one of the lesser known images. It's a panoramic of the landing site. So there's Neil's shadow. This is where he ventured 90 meters from the lunar module. You can see the crater here. The lunar module, the computer had him coming into land in that crater. He took over manual control and guided it down to this flat bit area here. But you imagine if the lunar module had come down, if Neil wasn't switched on and realised that, taking control, it would have been a complete disaster to have landed in that crater. And we'll have a close-up look at this a little bit closer in the future. There's the lunar module and the flag and the solar wind experiment, which we'll look at. But notice this view here, how relatively flat it is. The terrain is very flat. There's no hills or valleys. And that's something you'll notice with some of the other missions, lots of hills and valleys around them. So their mission was just land on a flat bit of the moon, make it technically as easy or as straightforward as possible, and get home again. So let's have a close-up view. That's inside the crater. And then let's just move across it, sweep across it. Isn't it absolutely gorgeous? And then if we just go in a bit here.
Why has that also got such a long shadow, but
it is, they've got a long shadow as well. We'll take questions at the end, but that's just, it's the shadow of the suns at a low angle when they come in. And they do that on purpose. They purposely come in at a sort of the early to mid-morning equivalent of the moon. So they've got shadows because we're going to talk about that shortly. It's the only way they can judge distances when they come and land is by the shadows. So there, you do see long shadows. Let's blow it up here. So the ladder would have been run the other side in the shade. And there's the flag, and there's the solar wind experiment, which we'll have a look again at both those very shortly. In fact, there's the flag there. So you can see it's been propped open with with wiring and net to make it look nice and appear to be flying. But what do you notice about Buzz standing there? What do you notice? You notice anything a bit different? You think, yeah, you think he's looking at the flag, don't you? But let's just move in. He's looking, he's looking back at you like that. So the suits are quite big and bulky, particularly the main bowl around the head. And it looks like they weren't all just straight ahead like that. They actually had a bit of room in there. And Buzz is actually inside there looking back towards Neil, taking the picture. That's quite cool. This is one of the very few pictures of Neil Armstrong working in the instrument bay on the side of the lunar module there. Neil had the camera most of the time. Buzz had it for some of the time, but he only took about 2 pictures of Neil. We'll never really know why. Yeah. So that's a close-up one. So you can say, yeah, I've seen a picture, because not many people have seen a picture of Neil Armstrong on the moon. They've seen Buzz Aldrin so many times, but not Neil. There he is. That's a lovely picture taken from inside. Buzz took that, looking through the window of the lunar module down at Neil. And what do you notice here? He's got his visor up. Almost all the pictures you'll see of the astronauts on the moon, they have their gold visor down. And that's to protect their eyes against the harsh ultraviolet light from the sun. And when they got into the shadows, they actually found it was more easy just to lift the shade up so they could, the visor up so they could see a little bit clearer. But suddenly it brings a human side instead of an astronaut figure. Big bulky thing, white suit, bouncing around on the moon with a gold visor, you can't see them. And you don't see too many images like that where you see the face. But to actually see Neil Armstrong's face on the surface of the moon is pretty special. And once again, this is an image of the 2 of them in the lunar module after their moonwalk. The moonwalk was scheduled to be after a few hours. They meant to have a sleep first. But of course, you've just landed on the moon. Who can go to sleep? So they convinced Mission Control to change the order of things. They went for the moonwalk. But you can see them, they're elated but exhausted. Yeah. So those are lovely shots there. which you don't often see. So that's Apollo 11. Apollo 12 followed in November of that year, and there was Pete Conrad, the commander, Al Bean, and Gordon, the guy Gordon in the middle there. So they were launched in November. Ironically, they were heading for the ocean of storms on the moon, and they launched in a rainstorm. They were struck by lightning once as it went up. They were heading on up at full speed, and then suddenly, whammo, they heard it bang, and all their instruments just went completely haywire, went out. Oh my gosh, a lesser sort of in control, cool person would have probably just aborted the mission. But Pete Conrad said, hang on a minute, we're still going, we're still heading up, let's just reboot. So they rebooted and everything went fine. Who said lightning can't strike in the same spot? That they were struck again a few seconds later by lightning again, but this time they were a little bit more relaxed about it and rebooted again. So that was quite ironic. Their mission, Apollo 11 had shown that they could get to the moon, was to do a precision landing. And there was an unmanned lander from 1967 called Surveyor 3. And that had, they thought, well, let's go back to Surveyor 3. Two reasons. One is let's prove we can do a pinpoint landing now. And two, let's go and have a look at it, see what shape it's in, bring some parts back to see how the materials fared, and over 2 years sitting in the vacuum of space. So this time, instead of one moonwalk, they did 2 moonwalks, a total of just short of 8 hours, 7 hours 45 minutes, versus 2.5 hour moonwalk. And they ventured 1,300 metres, in other words, 1.3 kilometres, as opposed to 90 metres. So you can see the immediately big advance, just the following mission. Instead of 22 kilograms, 34 kilograms. So 1.5, half as much again of rocks and samples that they brought back from the moon. That's their Pete Conrad next to the Surveyor 3 mission. You can see this is just on one side of a crater here, and that's the lunar module up here. So they made a pretty pinpoint landing. This image I put in here, this is an image taken by Al Bean of Pete Conrad just leaving the lunar module for the first time, going down the ladder for that very first time down there. So, and I put that in there because once again, this photograph to me just draws you in and just gives you that feeling of the sense of what it would have been like. So you can imagine that would have been, say, Buzz Aldrin with Neil going down the ladder for the very first time. That's exactly what it would have liked. Would have looked like. So I thought that was a lovely picture. Then we move on to Apollo 13. They didn't land on the moon. They had an oxygen tank that exploded en route to the moon, as you're probably aware. But I always put that in here just to remind people that they didn't get there, but they successfully were rescued. This is a shot taken just a few seconds before the explosion occurred. Before Houston, we have a problem, the famous saying was said. So there's just a few seconds beforehand. And ironically, here they are going to the moon for only the third time for a third landing. None of the networks were covering it. I think they were all covering like reruns of Lucille Ball and things like that. That's fair dinkum, yeah. So the major networks just weren't interested in it. But of course, the oxygen tank exploded. For those of you who are suspicious out there, it was Apollo 13, was launched on the 13th minute of the 13th hour, and it was April the 13th that the explosion happened. 4 13s all lined up in a row. Woo! There you go.
They survived.
But they survived, yeah, they did. So I just put that in there. Moving along, Apollo 14, February 1971. Al Shepard was the commander, Stu Roos, the command module pilot, and Ed Mitchell, the command module, the lunar module pilot. Their objective was go to a crater called Cone Crater, and it was the site of a lot of ejecta, sort of that's material that's being flung up and flung around you. Why go and visit a crater as your prime mission? When you go exploring a new area, what do you want to do to understand its geology? What do? You get a shovel out and drills out, don't you? You want to drill down deep and get some of the rocks way down below. Hello, nature's already done it for you here. Nature's dug down with impacts, have dug down deep and throwing rocks out. You know, you're talking many metres down, and nicely splayed them all out ready for you to pick up. So nature's done it for you. So that was their prime point. Instead of one moonwalk of Apollo 11, they did 2 moonwalks. Instead of 2.5 hours, we're now talking almost 9.5 hours. Ventured 1.5 kilometres from the lunar module as opposed to 90 metres for Apollo 11. They were on the moon for a total of 36 hours. So Al Shepard's worth mentioning. He was the oldest astronaut to go on the moon, age 48. The youngest was Charlie Duke from Apollo 16, who was aged 36. The average age was 38 for the astronauts walking on the moon. Neil Armstrong was 38. Al Shepard was the first American in space, May 1961, so it's quite ironic. There he is now as a commander of a mission walking on the moon. He was also an avid golfer, and he took up a 6-iron head with him and attached it to one of the lunar scoop handles, and took up a couple of golf balls and had a swipe. And there's an image of him there doing that, having a swipe at a golf ball. He was quoted as saying to Mission Control that both balls went for miles and miles. In actual fact, they worked out they went for about 24 and 40 metres, respectively.
You got all in one?
So this mission involved a lot of walking to this particular cone crater. It was about a 4.5 hour return trip up a 10-degree gradient, and I'll show you a picture of that shortly. So they decided, look, we're going to have a cart to carry our instruments in the rock. So they were the only mission just to have a nice sort of cart that they could carry with them. They returned 43 kilograms, essentially twice the amount of Apollo 11. And this is only the second mission on from Apollo 11. So this is where they walked with their moonwalk. So it was 4.5 hours. They covered 1.5 kilometres each way. They had a 10-degree gradient. This was the hard work. They found it absolutely exhausting work going up to the crater.
How fast did they walk on the moon? How many?
I don't know the exact speed. Yeah, we can work that out. I'll just keep them, but we can work that out. Yeah. So I think they stopped a lot as well, and they hopped and stopped.
I understand that.
Yeah.
I was just wondering how fast they could actually go on the moon.
Yeah, I'm unsure. Yeah, a lot slower going up hills. So this is some of the ejecta here. This is some of the rocks that were brought up from the crater that were lying around the outside. What do you notice about them? They're pale, aren't they? They're not dark. So that tells you straight away that these rocks came from the crust of the moon, not down deep. They wanted to know with a lot of the craters, were they from impacts or were they from volcanic in origin? And if they were from volcanic in origin, then you'd expect a lot of volcanic rocks, basalt rocks, which are very dark in colour, full of magnesium and manganese and iron minerals and so on. But the rocks were very pale, suggesting they were from the crust. The other thing is that the types of rocks that they were, in particular, a lot of them were what they call breccia, which are from impacts and compression. So that really pointed towards that these craters, certainly Cone Crater, was from an impact, not from volcanic activities. The rocks here were a type of rock called an orthosite, which is from the slow cooling of light elements like your calcium and your aluminium and stuff. That has floated to the top. When the moon would have been molten, and of course the light elements float to the top, the heavy ones sink down. And your aluminium and calcium is more at the top, and as they cool down slowly, they form into what they call anorthosite rocks, which these were. So this is all consistent with this particular crater being an impact base. So that was something that they got out of that. The other one I just put in here is that these images, this was taken a few kilometres away from up at Cone Crater. And you can see the lunar module here, another one of the astronauts walking. And the point being here is that it's almost impossible to judge distances on the moon, because you've got two things. One is you don't have an atmosphere, and with an atmosphere, it gets hazier the further something away is from you. So if you see something really clear, you know it's quite intuitive. It's close up, it's because it's clearer. Something's more fuzzy, it's further away. The other thing is there's no familiar things. There's no trees, street lamps, buildings, things that we just take for granted that help us work out distances and stuff. So for that reason, as I mentioned earlier, they use shadows. When the lunar module does come into land, they typically land about 10 a.m. lunar time. A lunar day is about 14 Earth days, and a lunar night's 14 Earth days, so 28 days in total. So they come in at sort of early to mid-morning, and as you notice, when shadows are nice long shadows, and it's cooler for the astronauts as well, it doesn't get so hot, so they're able to judge their distances by that when they come in and land. It gets hotter. Some of those later missions, which we'll talk about, were up to 3 Earth days on the moon. So you're getting to early afternoon lunar time. You know, of course, that's a hot period. Dave Scott noticed his wristwatch on the outside of his suit was starting to melt into the suit. So that's how hot it was getting. So these ones were done in the early to mid-mornings. So Apollo 15, Dave Scott, Al Warden, Jim Irwin, their objective this time was to say, look, we've done with sort of more flatter areas. We want to get more technical. Let's land in a high-tech region. Let's land in some highlands up amongst the mountains. Different geology. There was a lot of resistance from NASA at the time and doubt, should we be doing this? We don't want to, you know, have a problem. They said, no, we're ready for it. These guys were all gung-ho, cream of the cream test pilots. And there's a bit of a joke. Why do they need such a large Saturn V rocket to go to the moon? To get the astronauts' egos off the pad. So these guys were the cream of the test pilots. We're ready to go. We want to go up into the highlands. So, okay, away you go. So this was a 3-day stay. They did 3 moonwalks, not 1, not 2, but 3 moonwalks, 18.5 hours. And these guys were the first to use a lunar rover, which is here, which we'll talk more about shortly. That drove up to 4.8 kilometres. Never mind the 11 kilograms of samples brought back by Apollo 11, 77 kilograms. So this is where they landed. You can see up in here, up in the highlands. So you can see all the mountain ranges here. So right up in here, that was a high risk but a high skill landing. And this little picture here shows you where they are up in here, up in the highlands here. So there was Apollo 11, Sea of Tranquility, Apollo 12, the Ocean of Storms, 14 for Almira, and 15 up here in the Apennine Mountains. So I put this picture in here. They landed with a 10-degree tilt in the lunar module. You imagine 10-degree tilt. You know, when they go, you know, they lived 3 days like that. They would have had to take their suits off to go to sleep at night. They had hammocks at the stage for sleeping. Boy, you'd have your ears and eyes open for any creak or anything going wrong. But yeah, 10-degree angle they landed at. And there was a reason behind that. Here's this better picture here of the lunar module, the ascent stage, the descent stage. Here's the landing legs and the pads. But notice 3 of them, all 3 of them bar the one with the ladder because they didn't want anything interrupting with the ladder. But you can see these 6-foot probes coming down. And those are the probes, when they touched the surface, little light, contact light went on. They hit the light so they could switch the engines off and free fall down below. And they had a little bit of an ongoing competition. These guys were pretty competitive. Who had the quickest reflex to quickly slam that button before and have the biggest fall? Dave Scott won that competition and they fell the most, but they hit that lunar surface with a mighty thud. And you can see that not only that 10-degree angle, but the engine bell is almost sort of semi-impacted into the soil. So here is the rover. So the last 3 missions all used it. Electric motors to all 4 wheels. The wheels were made of aluminium and zinc with some titanium chevron treads. Top speed of 18 kilometres per hour, which was achieved on Apollo 17, and it went range about 36 kilometres. Now that was how far they could go, and it was restrained by the astronauts' oxygen time left in their tanks. And the logic behind that is in case it broke down, there's no point in travelling some huge distance that if you broke down, you had to walk back again, and it was a 4-hour walk, and you only had 3 hours of oxygen in your tank. So it was constantly constrained by how much oxygen they had in their tank. As the mission went on, they could go less and further with it. So these guys, Apollo 15, travelled up to a total of 28 kilometres. So never mind venturing 90 metres, they travelled a total of 28 kilometres, which of course allowed a lot more productive field geology, which we'll see some pictures of. Now let's try the sound. So this here is a nice little video. This is actually taken from Apollo 16, and they were taking the lunar module. It just needs to, yeah, perfect,
100%.
perfect, thank you, perfect. So they took it for a bit of a blast. So this is, Charlie Duke was filming it, John Young was driving it, and you'll see because of the combination of the low gravity and the uneven terrain, you'll see the whole thing bouncing up and down, and you'll see what they call rooster tails, and that's sort of all the material spinning up from the back of the wheels, but instead of just falling down, it tends to get splayed out and then just takes its time to slowly sink down to the surface and form what they call rooster tails. So let's see how we go with this. Let's get rid of the red dot and see how we go. Here we go.
When he hits the crater, if it starts bouncing, and when he gets his rooster tail, he makes a sharp turn. Hey, that was a good stop. Those wheels just locked. Mark off.
How cool is that? Yeah, taking it for a black, yeah.
Got four-wheel steering.
Yeah, 4 electric motors, yes, so presumably 4.
The front and back wheel steer.
Yeah. They had it all. Yeah, would you like one? I know where they're parked. You got one.
Having a good four-wheel drive of electricity.
Yeah. Okay, so here's another panoramic view that I've put together. This is Dave Scott working on the edge of Hadley Reel. Now, they've noticed these sort of small, if you will, like canyon type things that sort of wind round and round. Very steep walls, about 400 metres deep, as Hadley Reel is. Most likely, they think they're probably collapsed lava tubes. Just tubes of lavas that with time have just collapsed down. And yeah, this one winds on for about 100 kilometres. It's about 1.5 kilometres wide. So they were very careful not to go too close to the edge. You would not want to fall down there. It would be the end of you. You'd never get back again. Simple as that. So let's have a look at the landscape here. I just love these shots. Just take it all in. See the mountain in the background? There's just a bit of sun shining on the mountain because they're up in the highlands. Oh, that was good. Let's go back. Just love taking in that. Just imagine yourself being there, taking all that in. You can see why the astronauts just loved it. They just said it was just beautiful. So you notice that's a contrast to the landing site of Apollo 11 instead of that nice flat terrain. Completely different, but just different geology too. You can see all the tracks where they've been there. Now this is where Dave Scott did a science lesson. You know, probably learned at high school that things, irrespective of the mass, fall to the ground at the same time. And they were sort of a hammer and a feather, but you can't do that on Earth because the feather, of course, with the atmosphere, you know, sort of takes its time. So he thought he'd try it on the moon. And this was a painting. Al Bean, the lunar module pilot from Apollo 12, he got into painting when he'd finished with the astronauts' corps. And he did a whole series of moonscapes of the astronauts. This is one of them, and they're available. They sell for very high prices. So that's a photograph of him, but there's more. I've got a treat. It's a little bit grainy, but this is the video of Dave Scott doing it. Cool, eh?
Mr. Galileo was correct in his findings.
And his comment about the falcon feather, because they named the lunar modules and the command module, and their lunar module was called the Falcon. So it just made sense, yeah. That's very cool. So moving along to Apollo 16, you had John Young, the commander, Charlie Duke, the lunar module pilot, and command module pilot was Ken Mattingly. Charlie Duke is the very southern voice. You're going to get an interview with him later coming up here. He's got that real southern accent, and he was the guy in Capcom, in Apollo 11, when they landed Tranquility Base here, the Eagle has landed. He says, "We copied out, Eagle. You got a bunch of boys about town blue. We're breathing again. Thanks a lot." That was him with his real southern accent. So he talks later on. I got one of him. So they also landed up in some highlands here, the Descartes highland regions, and they thought all the evidence was pointing, okay, it seems these are craters on the lunar impact. Surely this region must be volcanic in nature. Surely. So they went up there to have a look. 3 moonwalks, almost 20 and a half hours this time. So never mind 1 2.5 hour moonwalk and venturing 90 metres. You're talking 3 moonwalks, total of 20 hours, 24 minutes, 4.5 kilometres they ventured away. Never mind 22 kilograms, you've got up to 95 kilograms. And you'll see in your handout I've got nice little graphs, bar graphs showing you how with each mission all those things were going up and up. So they visited this crater here called Plum Crater. And the importance of this was it was a completely different region in appearance, geologically different appearance region from Cone Crater from Apollo 14. So they went here to once again to get the rocks around the side. So this was about 10 metres deep down here that the rocks were all spewed up as form of ejecta. And the results showed these were breccia rocks, in other words, rocks that have been compressed and impacted as opposed to volcanic basalt rocks and so on. So these were definitely impacts, not volcanic. They came across this boulder, they called it House Rock. So it's a little bit deceiving because the astronauts actually, it was hard to judge distance. He's a little bit off to one side here, but this is 12 metres high, 16 times 20 metres across, and it's visible from lunar orbit, which I will show you later on. You can see it from lunar orbit. Look at this. Look at how it dwarfs the lunar rover there. Totally dwarfs it. House Rock. Once again, just look across here. This is a bit flat, but look all these hills and mountains up in here. Remember, it's hard to judge distances, how far away. Now, astronauts would often comment that see something looks pretty close, and they'd walk and they'd walk and they'd walk. I'm not getting very far. Walk and walk. No, it can't be very far away. Walk and walk and walk. It was really hard. So it's very, very deceiving. But I just love that picture just for the rock, but just looking around. Look at this boulder field on a slope. So that's a 22-degree slope, sort of those rocks and boulders. Imagine on that, but that's what the lunar rover could handle. It could go up hills like that. So that would have exhausted them going up. The Apollo 14 astronauts were exhausted going up that 10-degree slope. It's hard work. These guys went up 22 degrees with the lunar rover there. But look, all the rock fields and stuff. Just imagine being there. That's if that was here on Earth, you're at high risk of falling over and spraining your ankle, or breaking an ankle for that matter. So once again, that's a scene I just absolutely love. And look at the hills; it's just hard to judge the distances, but you get the feeling, they're up in the highlands up in here. Isn't it beautiful? Stone Mountain. Just love that. This became quite an ionic picture. So this is John Young jumping up here. And there's 3 points here. One is low gravity, so he's able to jump for joy. Last time I tried that, I got my head hit by a fan. So you can see him jumping up. That was a really cool picture. The other one, as I mentioned, has red stripes. Notice the red stripes. From Apollo 15 onwards, all the astronauts, the commanders, had red stripes. And the reason behind that is that those earlier missions, a lot of the pictures that the astronauts had taken, they look back, days and weeks later. Who was that? Oh, I can't remember if that was me or that was you. They couldn't decipher some of them. They thought, well, let's give the commander some red stripes so we can see who they are in later pictures. And it makes them feel important. Look, I've got red stripes. And the other one in the back here is this instrument here is an ultraviolet spectrograph. So ultraviolet light is absorbed by our atmosphere. So any research looking at the sun in ultraviolet, but looking at high energy events like supernova explosions and so on in the galaxy, if you're going to study it in ultraviolet wavelengths, you have to be above Earth's atmosphere. But of course, they wouldn't have had the technology to have space telescopes in those days, plus you've got an unstable platform. Suddenly here you're on a nice stable terra firma platform, the moon, and you've got no atmosphere, so you can see ultraviolet light and study it. So that was designed to study light in the far ultraviolet light there, so that was just a unique opportunity, which they did. Of course, they've got it set up in the shade because they don't want the sun burning it out. This is a lovely picture here. So this here is what they call a magnetometer. So it studies looking for magnetic field lines in the region, which we're going to look at more closely later on. The flag here, and here's the track marks. But just enjoy that, and we'll just go for a wander.
Did they always put the flag near the lunar module?
Yes, yeah. Fairly close, yeah. That's John Young. You can tell by stripes on his suit there. Beautiful shot of the lunar module. All those track marks and boot marks will remain there forever because there's no wind. There you go, isn't it beautiful? God, that was good. Let's go back again. Go back a bit quicker. So just take in that scenery, isn't it gorgeous? Once again, you can tell it's up in the highlands. Okay, so moving along to Apollo 17, the last of the mission, and you had Gene Cernan, the commander here, Jack Schmitt, or Harrison Schmitt, was the lunar module pilot, and Ron Evans, the command module pilot. So their objective was also to go up into the highlands, called the Taurus-Littrow Valley up in the highlands. And of note, Harrison, or Jack Schmitt, was the first professional geologist. They thought, we've got one mission left. Let's get a proper geologist up there. A lot of the astronauts were upset about that because they, it was taking one of those guys' seats. But they learned to have a high respect for him. He trained himself up and became a very top pilot and proved himself up there. So that was, I think that was a very good decision. 3 moonwalks, 22 hours, 24 minutes, travelled 36 kilometres on the rover, and the total, that was in total, but the furthest they went 7.5 kilometres versus your 90 metres from Apollo 11. 111 kilograms. 5 times out of Apollo 11. You can see how Neil and Buzz would have been just drooling on their TV screens at this stage. My gosh. Yeah. So this is where they landed up here, in the Taurus-Littrow region, up in the highlands, or up in here. So there they are, right there. Look at all these mountains all around them. In they went. They did, these are their 3 EVAs, or moonwalks. There's one here that went around here, and that's their second EVA, or extravehicular activity it stands for. Yeah. So, this is a couple of interesting pictures. So, this was and I remember reading this in the newspaper at the time. They discovered orange soil. Wow. So that was Jack Schmitt who discovered it, the geologist. He said, wow, look, I've got some orange soil here. So they naturally took samples of that to take back. And it turned out that this was the only bit of volcanic, sort of evidence of volcanic activity on the moon. There were glass beads rich in titanium, iron oxide, and zinc. And where you get glass beads form usually from extreme temperatures, usually molten. That's then flung up high into above the surface, cools down very quickly, and settles back down as it lands on the surface. And that's how you get sort of spherical glass, if you will, sort of little spheres from that process, but also just what was in them and so on. So it told them that that was from volcanic activity. On the right here, you'll see Gene Cernan covered in grime and grit, looking very grubby. I'm sure his mother wasn't very proud of him in that picture. The lunar dust they found very adhesive, abrasive, and irritating. It stuck to everything, to their suits. Before they went back into the command module, they had a wire brush to brush themselves each down with, but still, it just got in there, went everywhere. It was very abrasive, in particular for rubber seals around where their gloves and their boots fitted on, around where their helmets were. They realised that's a real problem the astronauts going back to the moon are going to have to deal with. It's very abrasive. It's also very irritating. Some of the astronauts reported that they had like hay fever going on. They said it smelt like spent gunpowder, is what they said it smelt like. At all costs, they wanted to avoid getting that into the command service module because that was their ride home. So they brushed themselves at the time. But when they launched up in the ascent module and then joined up with the command module, they would purposely, when they opened up the hatch, they sent a very slight gradient, a slight air gradient, higher pressure in the command module, driving into the lunar module to minimize any dust floating into the command module. And it was even Apollo 12 where the command module made the other two guys strip right down to the underwear to get back in. They said, no, you strip right down. I do not want any of that dust in here getting in here. Thanks very much. Clean yourselves up, guys. Okay, now, so that's covered the missions. Let's put it another human side to it as well. The astronauts on the moon had a lot of falls. So, they had to walk around very clumsily. And that's why I had difficulty answering the question, how fast do they walk? Gosh, it was all over the place. So have a look at this. There's a little montage, if you will, about a minute of various falls on the moon.
Tranquility Base here. The Eagle has landed.
Yeah, so it wasn't all roses up there. There was one fall in particular that they didn't get here because it wasn't so obviously seen on the camera. It was behind the lunar module. But I remember seeing it was behind the lunar rover rather, and I saw it again on film yesterday, and they didn't put it in here. But I think probably a few of you would have seen it at the time. It was Charlie Duke when he fell on his back. I remember it very clearly at the time. He jumped up to see how high he could jump, and he lost his balance, went backwards, and went straight back onto his backpack. And they could do a nice little interview with him here talking about that.
Oh, it was scary, really scary, because the backpack is your life support system. It's got your oxygen, all the plumbing, all the regulators, all the batteries, all the electronics, and if it breaks, you're dead, especially if you spring a big leak. And so when I fell over backwards, it was fearful. And the only time I had a moment of fear, and I realized I got to do something. So I rolled right and broke my fall, bounced onto my back, and my heart was just pounding. John Young, my commander, I remember him looking down at me and said, "That wasn't very smart, Charlie." And I said, "Well, yeah, you're right. Help me up." So he helped me up. And but you could tell that I was okay because the pressure was normal, all the levels of oxygen were normal, the batteries and all of that stuff. And so I began to calm down. The mission control was very, very angry with this stupid stuff. And no more Moon Olympics, and no more high jumps, and no more this. Get back inside, guys. So I dropped, right before that, I dropped a picture of my family on the moon. That was Charles was 7 at the time, and his brother was 5, almost 5. So we had this family picture, and on the back of the picture we said, "This is the family of astronauts." Charlie Duke from planet Earth, who landed on the moon in April '72. We all signed it. And I dropped it on the moon, and it's the only family picture ever made it to the moon. We were always looking for what's over the next ridge. What are we going to do here? What are we going to see over here? So this excitement and this adventure of seeing the moon in detail was remarkable. It never left us. And so we didn't want to come back. We were so enthralled with the beauty of the moon. We felt right at home, but you knew it was that all your equipment had to hold together or you were going to die. Yeah. But you never worried about it. It was always like a sense of belonging. Buzz Aldrin called it magnificent desolation, which it was, but it was one of the most beautiful spots I'd ever seen. It just untouched, unspoiled. Kept having this thought, nobody's ever been here before.
Yeah, it was a great little interview. While that was on, I fixed my own little memory lapse. Dick Gordon was the command module pilot. Gordon, I was trying to think of Dick Gordon. I knew it, and I thought about it. Okay, so that's the missions and a sort of human side to it. Let's look at some of the lunar science. As well as the field geology that the astronauts saw, yes, they set up many lunar experiments, 6 in particular, that continued transmitting data for many years. The laser reflector ranges, they still operate today. So these are the 6 instruments they set up here, which we'll go over each one very briefly. So let's do that. So the seismometer, that's it, sitting right there. You know, they were interested, if the moon, is it geologically active? So do they have moonquakes like we have on earthquakes? And it showed that despite the moon is not geologically active, they does experience some moonquakes driven by the tidal forces, gravitational force between the Earth and the moon. Just sort of quietly stretches the moon a little bit and you get very subtle moonquakes. This is the magnetometer that you saw in the nice panoramic view of Apollo 15 that you saw there. So what that does, it measures magnetic field lines. And the question was, does the moon, what does it have in the way of magnetic field lines? They discovered it does not have a global magnetosphere like Earth has magnetic field lines that sort of enshroud, go right around the Earth, called a global magnetosphere. It does not have one of those, but it does have localized regions of magnetic fields that vary in strength between regions, probably due to different mineral concentrations in different regions of the moon, but also within time. So in the same region, the degree of magnetic fields may fluctuate, and that's probably because the moon's orbit around the Earth and then from secondary around the sun been influenced by the Earth's and the sun's magnetic fields. It sort of tends to alter the moon's as well. So, does heat, is the moon geologically active? Is there a little bit of activity? Is there any heat just quietly radiating out from the moon? So they drilled these, and when you saw the astronauts there drilling down deep, you know, they're falling over stuff, driving in, a lot of that was trying to put in these, the heat flow experiment. And it showed they went in 2.3 meters, and there was really no appreciable heat flow going on the moon. So this is the laser ranger, And the purpose of putting this is to answer the question they'd worked out with their physics that the moon should be receding from the Earth about 3.8 centimetres per year. And the logic behind that is because of the tides which are created on Earth, created by the moon. And the moon is always the tide's rather slightly ahead of the moon. So in which case it's slowing the moon's orbit down very, very slowly, and it's pushing the moon out a little bit. Actually, no, pardon me, it's the opposite. It's driving the moon forward. So our tide's ahead of the moon, so that's pushing the moon forward a little bit. And as you go into slightly faster, your orbit goes out a little bit further. And that's why the Earth also counters that by very subtly slowing down. Our days are slower than they were sort of hundreds of thousands and millions of years ago. It's because of that. And so they shine a laser beam from Earth up towards these reflectors and back again, and they get a very accurate measurement of the distance between Earth and the moon. And exactly as the physics predicted, the moon is receding from the Earth 3.8 centimetres per year. So is there any appreciable atmosphere? You know, we know there's no significant atmosphere, but is there something going on up there? Yeah, it does technically have an atmosphere, but it's very, very tenuous, and just some potassium and helium and argon predominantly, but very, very tenuous, but technically there is one. This is the solar wind experiment. Of course, the solar wind consists of charged particles emanating out from the sun. And of course, you can't measure those on Earth or identify them because of our global magnetosphere. That entraps all those charged particles. But suddenly here you are on the moon, perfect place to set up an experiment. And the foil is designed where it sort of traps, if you will, the charged particles, get embedded with that. The first 5 missions, they had it deployed, and then they roll it back up again and take it back home. And it concluded that 95% of the solar wind is protons and electrons in equal numbers, and some helium nuclei, also known as alpha particles. That's a really iconic picture as well. So the moon rocks, they brought back a total, in case those of you are adding up all along. If those who got 382 are correct, 382 kilograms of rocks and soils returned. So yeah, what does that tell us about the moon and the history of the moon and history of the solar system? It tells us a lot. So first up, the rocks are extremely old compared with Earth's rocks. And just putting things in context here, meteorites, radiometric dating of meteorites suggests that the solar system and the Earth is about 4.6 billion years old. Of course, the rocks on Earth have undergone geological activity, chemical weathering, wind and water weathering, and so on. So our rocks on the Earth aren't as old as that. They're quite a bit younger than that on the Earth. They're about 4.2 billion years or something along those lines. The Highland crust samples on the moon, they aged about 4.4 billion years old. It would take about 100 million years, because the body's initially quite molten, and it would have taken about 100 million years for it to cool down, which suggests that the moon probably formed about 4.5 billion years ago. The Mare, now let's just point things out here. So the highlands here are these white bits. They look very pale. Why? Because that was the original crust from the moon, full of your calcium and your aluminium and stuff, that very pale rock, and orthosite rocks. The Mare samples, and that refers to what they call the seas and the oceans, these dark patches here of the moon. And why are they like that? And they're like that because they had some pretty massive impacts early on in the moon's history. If you can imagine, you've got a crust of light material and orthositic rock. Then you've got your mantle is consisting of your heavy elements that have just quietly sunken down in its molten state. Your magnesium, your manganese, your iron minerals, and so on. So they're a lot darker, but you get some massive big asteroids coming down, slamming into the moon, creating these huge, big, deep basins. And little cracks and fissures occur in them. And some of the molten mantle starts working its way up and start through those cracks and fissures and floods those massive big basins. And that's why they are the flat regions of the moon, the flat dark regions. Here you can see the big impacts, the big basins, because they've been filled with the darker material that's come up and filled that in. So the mare samples naturally are going to be a lot younger. So that tells you when the big impacts happened, between 3 and 3.5 billion years ago. And the rocks all there, instead of being the orthositic rocks up here, these were very much volcanic basaltic rocks, the dark colour ones in here. So that tells you a lot about how the moon formed, when it formed, how it formed, and some of it, how it evolved. They were also all igneous rock. In other words, rock that had come from ultimately from molten lava. There was no sedimentary rock. Sedimentary rock meaning that something's been weathered by wind or rain, and then it's settled down, compacted, usually at the bottom of rivers or oceans or water, and just formed into sediment from there. So there was no sedimentary rock. The moon has been pretty essentially dry in that regards. Also, the fact that all the rocks were igneous infers the outer proportion of the moon was once completely molten. In other words, it wasn't some solid bits joining up together. It was all molten at one point in its past. Probably about 4.5 billion years ago, and over the 100 million years it normally would take for it to cool down for the rocks to be 4.4 billion years old now. So the rock types were mostly basalt, as I mentioned, titanium, manganese, some iron-rich minerals that cause the dark maria. Then orthositic, that's the things like the light elements like your aluminium, calcium, that's cooled down slowly, as you would expect a crust to do. It slows down very coolly, causes those white highlands there. And a lot of the rocks were breccia, which means they've gone through multiple impacts events. They're just rocks that have been just smashed together and impacted. Low and volatile, things like your sodium, potassium and water, relatively low amounts of those compared with Earth, and that tells you that at some stage early in the moon's history it experienced a significant amount of heat. That, with the fact that the oxygen isotopes, we talked about those before, oxygen isotopes refers to just different amounts of neutrons in the nucleus of the oxygen. But comparing the ratios, oxygen ratios differ according to how further you go out from the sun, different places in the solar system. And that's to do a lot with the ultraviolet radiation and various chemical composition differences in the initial protoplanetary disk, how the planets first formed in. So the oxygen isotope ratios differ. The oxygen isotope ratios in the moon match the Earth. That tells us that the origin of the moon ultimately came from the same orbital region. It wasn't some rock heading from the outer solar system coming in and getting captured. It formed in the same orbital region as that of the Earth. And all that, along with the experiencing of the heat and everything that ties in, and I did a whole talk on it, you'll see it online if you missed it, on the website here, the giant impact hypothesis, where early on in the solar system, probably after about 100 million years, a large object would have been molten, Earth would have been molten. This would have been about the size of Mars, they called it Theia, and at a glancing blow, it came in and struck the Earth. It's always had its problems, but they've solved that recently with some supercomputer models, whereby most of Theia was actually absorbed right into the Earth, and it was a large chunk of Earth's mantle that got flung up outside the Roche area, so it was relatively stable, and it formed into the moon from there. That would tie in how the moon's composition is very similar to the Earth's mantle. Ties in beautifully with it all. So that's what sort of the rocks are very much in keeping with. The other thing a lot of science that was very useful for planetary science is crater dating. So what's all that about? Well, they were able to observe different regions of the moon where the astronauts were getting their rocks from. In the command module, they were able to take photographs and make note and record specifically of the numbers and sizes of the craters from the regions they got the rocks from. And of course, the rocks went back to Earth and got radiometric dated. So they're able to correlate the radiometric dating of the rock samples with the types, the sizes, and the numbers of craters. So that was very good because it improved the understanding of the solar system's history, because most of the craters were formed. There was a early period in the solar system whereby there was a lot of rubble that hadn't really formed into planets. And then the outer planets, particularly Uranus and particularly Neptune, headed outwards to the outer parts of the solar system and created havoc and sent a huge barrage over probably, they say, anywhere between 2 and 20 million years, big barrage of asteroids towards the inner solar system that would have bombarded all the inner solar system, like Mercury, you see it, Earth would have copped it, Mars as well, but the Moon really copped it, didn't have an atmosphere. And they're able to, for that, they call it the late heavy bombardment phase. The first phase, of course, would have been when planets were first forming, it was rocks colliding everywhere. So they call it the late heavy bombardment period. And they're able, of course, by looking at the size and the numbers of craters, dating the rocks, that told them when that occurred. But also, it allows estimations of the ages of other planets. For example, Mars. You just do your different surfaces, you do your counting of your craters, the size of your craters, and you now correlate that with the history of the Moon, and it'll tell you roughly the date of your surfaces. So that was something more they got out of it. So the landing sites today, where they are, both NASA and the Japanese Space Agency have orbiters, high resolution imaging of the Moon, really in 3D mapping it, and it's for understanding the geology of the Moon, but future exploration of the Moon, where to go. So they've done that, and they're doing all of the Moon, but they've got the landing sites where I'll show you of interest. And here's Apollo 11's landing site. Notice how all flat it is here. So here we go. So here's the camera that they set up to film the lunar module, and there's, I put the lunar module there.
When it says discarded cover, what was that?
Oh, okay, that is, there's covers over their instruments and stuff that they had here. They discarded quite a bit.
Well, don't tell me.
Yeah.
You break my heart.
Oh, I was going to get into all the toiletry things.
No.
Yeah, no, they discarded a lot of things. Yeah, weight was the key. When they lifted off the Moon, anything that weighed anything got left behind. The bottom line. LSAP, that stands for the Apollo Lunar Surface Experiments that they all set up there. So that's those instruments that we talked earlier on. So here is the descent stage of the lunar module. Here's the Surveyor 3, that's it there. Remember when they landed, that pinpoint landing? And there's the crater, on the edge of the crater, and there's the other side, was the lunar module. Apollo 14, here's the descent stage of the lunar module. You're wondering why I'm talking about ascent stage and descent stage, we'll get to that shortly. Here's where they set up their experimental station. Notice all their footprints. See all their footprints? Apollo 15, of course, they were the first to have the lunar rover, and there's the lunar rover. If you want another one, Niven, there it is there, parked up there. There's the descent stage of the lunar module. You can see where they set the experiments, and you can see the tracks of the lunar rover and their foot tracks as well. Apollo 16, there's House Rock, and there it is there from lunar orbit. You can see it. And there's all the tracks, the lunar module, lunar rover. Apollo 17, now I've circled that for a reason. So there's the descent stage of the lunar module, and there's where the lunar rover, where they parked it. I'll come back to that shortly. Just another bit of the human side. So 24 astronauts have travelled to the Moon. 12 walked on the surface of the Moon. There are 6 surviving astronauts of those. 4 of them are moonwalkers. So there they are. Those are the 4 surviving moonwalkers. They're getting sort of on in years. The 2 others that didn't land on the Moon but went to the Moon, Jim Lovell twice went to the Moon, Apollo 8 and Apollo 13, didn't get to walk on the Moon. He's now aged 97, Jim Lovell. Fred Hayes was in Apollo 13, so went to the Moon, didn't land on the Moon. He's aged 93, still alive. And there you go, a little bit about the human side of things. So, the reason I circled with Apollo 17, so here's the lunar module, and you can tell it's Gene Cernan, the commander, because he's got his stripes on there. But what do you see at the front here? This thing here, the camera. And the camera was interesting because it enabled them another set of eyes, if you will, to record the 2 astronauts when they're working geology. So they just didn't have one geologist on the field, but also those other missions as well, where they didn't have a geologist in the field. There'd be a whole room full of geologists back at mission control. And that camera was able to move, they were to move the camera around. They were able to say, hey, Gene, that rock a little bit to your left, can you please go over there and pick it up and show it to the camera? No, put that down. That one, maybe try that one over there. That looks interesting. The camera and the geologists were in control of the camera, and they'd see a rock and they'd direct the astronaut, and the astronaut would pick that rock up and show it to them. Yeah, no, that's good. Yeah, label that such and such. Put that in the bag. Yeah, we want that, please. So the geologists, you had a dozen or so geologists back at Mission Control, keeping an eye out for what the astronauts were doing and directing them what to pick up and where to go and what to explore. But they also used it. Remember, I started the talk, I haven't quite finished, but this is just about the astronauts. We started the talk about the missions. We started the bookend with the very first landing. I'm going to show you the very last, them leaving now. And the lunar module's in two halves, the ascent stage and the descent stage. Comes down as a whole and lands, and then it's just the ascent stage that takes off. Two reasons. One is you don't need all that stuff you needed to land, like legs and extra fuel and stuff. It's all about weight. Leave that behind. Anything you don't need, leave behind. Just take off with the bare minimum of what you need, yourselves and your samples. And it acts as a nice, stable launching platform for them as well, for the ascent stage. So they filmed it. So I thought I'd just bookend it with this. Yep, that's still on. Okay, here we go. It is. There you go. But a few of you may not have seen that. I thought it was a nice way of bookending it, sort of, yeah. But I've put a few other little bits and pieces here. So I've shown you that from 1969 to 1972, 12 men have walked on the moon's surface, and I hope you've seen now how each successive mission, science-wise, technology-wise, was successfully more advanced than the previous missions. Total of 382 kilograms was moon rocks and soil was returned to Earth for geological study of both the moon and the solar system's history. Many surface experiments set up to determine the moon's physical properties. So yeah, Apollo 11 was first, but 5 successful landings followed. That's your take-home message. I hope you've enjoyed the Apollo moon landings, the lost missions. Thank you very much. Are there any questions? Otherwise, I've got a question.
When's the next ETA back to the moon? Is it Artemis?
What, sorry? Oh, the next mission? Yeah. I did a talk on that, the Artemis mission. But I think Trump's got his boots into that, really slashing the budget. But it is the Artemis 2, which is just going to go around the moon. That's due to fly, I think, sometime in the next 6 to 12 months. And then Artemis 3, I know that's been given the nod to the next manned mission to the moon. The initial thing was they were hoping to have a permanently based moon base by 2030. And I did that talk saying, look, it's going to be 2033 at the absolute earliest, assuming there's no technical hiccups and like budget cuts or terrible disasters or anything like that. But that's really totally in jeopardy right now, totally. Last time I heard it was going to stop at Artemis 3, sadly. Yeah.
What about unmanned?
It's Artemis 2. And there'll be they're sending unmanned, called CLIPS, the Commercial Lunar Investigation Probes, programs, whereby a lot of private companies are being paid by NASA to land unmanned craft on the moon to do reconnaissance missions for future landings, to see where the minerals are, where the water is in particular, send rovers deep down into those craters at the poles. China's doing it as well, Japan's doing it. I don't know if they're bringing rocks back. Yeah, I think that is their aim. I don't know if I think they've had a small return sample. Yeah.
They were donating it to some of them to a university in
Yep.
the UK.
Yep, to look into it. Yep. Yeah, Alistair.
So the first mission, 22 kilos rock.
Yes.
The last one about 900, whatever.
111.
Did they increase the power of the ascent engine or just...
Absolutely, like all things. You see a motor car from 50 years ago, it looks sort of, apart from the sort of design and stuff, you think, what's different? Still got a bonnet and a hood and stuff. It's totally different underneath the hood and stuff. The Saturn V was constantly getting advanced because it had to take more weight. But yes, the lunar module was getting more advanced with every one. It was just getting more powerful because they took more and more, the lunar rover for starters, but they were taking more and more experiments up. So each lunar module and each Saturn V was getting more and more advanced with each mission. Yep, to handle more weight. Correct. Yep. That's about right, because I'm going to put some more on the screen in a minute, guys. Yeah, sorry.
The lunar rovers.
Yes.
How did they get onto the moon?
Yes, so the lunar rovers, how did they get them onto? They were beautifully folded up, beautifully. They were in the instrument bay. They pulled a lever, so they're all folded up, and they pulled a lever, and it would sort of pretty much sort of flop out like that. And then a flick of it, to some levers, and the wheels would spring into actions, the seats would flick up, and so on. So they're neatly folded up, tucked into the side of the instrument bay. Yeah, but isn't that just ingenious in its own right? It's every single thing you look at is just an engineering miracle. Yeah, the back there. Yeah.
How far off the moon's surface was the command module, and how long did it take for the ascent module to get back to the...
Yes. Yep. My understanding it's about 60, and I'm going for miles here because the Americans quote it, about 60 miles in altitude for the command module. And how long did it take? And it wasn't long. I think you're talking like, depends where they were, but they timed it beautifully anyway. You're talking like sort of between 10 and 20 minutes. You're talking minutes. You're not talking hours. Even then, to go down to the moon, you were talking the whole descent thing. You might have been talking 12 minutes or so. There was one case they were stuck up there, interesting case, Apollo 16. They had separated from the command module, due to go down, and then Ken Mattington and the command module pilot said, Houston, I've got a problem here. We've got computer issues. And there's a rule. Other guys do not go down and land. Doesn't matter how good the aircraft is until you know that command module pilot is fully intact. So they spent about 2.5 hours just in orbit in the lunar module, just killing time, waiting for NASA to sort out the technical problem with the computers and the command module pilot. And in that time, Apollo 15, Jim Irwin was noted to go in without some cardiac arrhythmias when he was walking on the moon. They found it was some atrial fibrillation, and it was due to low potassium levels. He sweated so much that it was hard work on the moon. So for Apollo 16 or 17, the astronauts had some orange juice enriched with potassium strapped to the side, a little tube they could just go into the side of their helmets. And but of course they're only going down to the surface of the moon in a few minutes, so they didn't really worry too much about that. They'd be under the control of gravity again. But of course they're up there for 2.5 hours, so all this orange just seeped out and just went all throughout his space helmet. And he had orange hair. His hair got dyed orange. Charlie Duke. So there's a little anecdotal story for you. Yes, yeah, Tony.
What's the story about all the gold foil up there?
Gold, because it was the lunar module wrapped in. When you say what's the story, what do you mean about this?
Why do they have it?
Oh, I think
Is it real gold?
I assume so. I haven't looked into that, Tony, but I'm totally aware that a lot of that stuff was wrapped up in foil, gold foil. I think it's lightweight. It's a good reflector for reflecting heat, to protect your instruments and so on. There were some parts of the lunar module, I believe, and I believe the astronauts confirmed there were some parts. They say, weren't there some parts that were just purely foil and you could have put your hand through it? Yes, but they were in regions that were tucked out of the way. But it was ideally it was meant to be lightweight as possible and to protect instruments against heat as well. Now, why they chose gold, that's not my field of expertise, but I'm led to believe, there's gold foil up there. Interesting, yeah.
And something else that's interesting is that on the quiz show Who Wants to Be a Millionaire, in one episode, the $1 million question was how many men had walked on the moon.
Yes, yeah. You'll be surprised how the varied answers you get on that one too. I gave a talk on last Tuesday at Whangaparao Library. It was a group of kids aged from sort of about 5 or 6 right up to about 12, 13, 14. And I asked the question, how many people have walked on the moon? And the number of hands that went up, 12. These kids are clued on. What makes the sun heat and light? Nuclear fusion. Kids this age. Yeah, great. But that is a question. That sometimes comes up at pub quizzes and stuff too. and a number of people who don't know. Yeah. Yes.
And I'm sure I read somewhere that the dudes up in the, Michael Collins and all of those, they were told that if they didn't come back, too bad, take off, you're going home, just leave the others.
Yeah, they couldn't do anything else. And Michael Collins talks about that quite openly.
Yeah.
And he said none of them wanted to talk about it, but you feel like say, hey guys, what are your chances of coming back? They spoke about it afterwards, and Neil and Buzz both thought 50-50 chance that they'd come back. And Collins had the instructions, you got to come home. And he said, I would have been a marked man. Yeah. He said, I would have come back, but he reluctantly, he said, I would have been a marked man, but he had no choice, but that was the plan. Yeah. Yep. The astronauts would have stayed on the moon conscious for as long as they could. Just it was the nature of them. Never give up and constantly feed data back. Even if you're doomed, feed data back, for the next mission to learn and so on. But yeah. And the other one is the Gemini missions. How they opened the hatch and one guy had to get out. I think it was Jim Stanford was the commander. Gene Cernan was doing the spacewalk, and he had trouble getting back in. And he was told, if you can't, you just got to shut that hatch and have him hanging out the side. He would have got frizzled up, of course. There was no other option. It's not nice, but no other option. Yeah. So they were brave men, And that, yeah.
Just thinking about the solar radiation, were they at risk from solar flares?
Were they at risk of solar flares and radiation? Absolutely they were. They were lucky. I think it was between Apollo, might have been between 15 and 16 or 16 and 17. There was between two of those latter missions where there was a solar flare, and they would have been seriously sick. They were vulnerable. They were just damn lucky. Yeah.
They wouldn't have been protected from a solar flare.
No, their spacesuits. No, correct. They would have had significant radiation exposure, depending on the severity, the degree of the flare.
That makes the question with the Artemis project.
Yes.
Yeah. Do they have any way of protecting?
Yes. Yes, they do. Yeah, lunar samples, lunar soil is a very, very good one. But yes, they've got things, and I talk about it in my talk on humans in space, the hazards. They've got this little vest called the AstroRad vest, and it protects all the vital organs: breast, lungs, gut, ovaries, bone marrow in the pelvis, so on, and it protects all those. And it's very, very effective, easy for them to don, because a solar particle event, you can see them and you can warn the astronauts, hey guys, buckle in. Within the space station, they have where the living compartments are, they have proper shield, they have Kevlar little areas in there that are extra protected. With tiles and so on, that's dropped the exposure rate by about 50%. They're in the living and in the sleeping quarters, so they can just go to those areas.
I read something they're far more in danger on the moon, say, than the ISS.
Oh, they're far in the moon because they didn't have this technology. They didn't have the technology. They were vulnerable. The bottom line is they were vulnerable and they were damn lucky.
No, I meant on the International Space Station.
Yes.
They're not as much at risk as on the moon.
Yeah, they are, because admittedly they're not. Yeah, correct. They're not. They still have some protection. They still have some protection. Yeah. But yeah, you are more vulnerable on the moon. But the Artemis project, they are well advanced with that. Yep. Yeah.
The temperature range that they have on the moon's surface.
Yes.
What's that like?
Yes, that's going back. God, I'm scratching my head here. In the equator, I think you're talking about 240 degrees for your hottest, and in your shade, you're talking about minus 120. Remember rightly? Because when they're going back to the South Pole, that's where they want to go. Why? Because that's where the water is. In those permanently shaded regions, you're talking, that have never ever seen the sunlight. You're talking way down in the minus 130, and probably some cooler. Yeah. So it's either because you've got no atmosphere, so it's either really hot or really cool. I just sort of throw something else in here, because usually often when you give a general audience talk, always someone say, look, what do you say to these people? Say, oh, did they go to the moon? And still I get people who ask me, genuine people, they're not saying they didn't go to the moon, but genuine people who don't know any better, because they hear all this rubbish, BS and stuff on YouTube, whatever. They go, did they go to the moon? I get confused. Did they go? And they're asking a genuine question. I tell them, look, there are always ignorant fools who try to belittle the achievements of great people. History that's humanity. They're littered with that. But I say, look, have a look at this. One hand, you have the most witnessed event in human history. It is literally the most witnessed human event in human history. 400,000 top engineers, scientists, technicians, test pilots working on... There were 28 prior missions to Apollo 11. 28. People just think they built this rocket, called it Apollo 11, and away they went. Someone asked me to talk once, why did they call it Apollo 11? I said, well, it's the 11th Apollo mission. And it was a genuine, it wasn't a smart-ass one, it was a genuine one. But people don't realise that over 10 years to achieve 6 successful manned landings. Millions witnessed the launch on Earth orbit, and that's the hardest part, it's getting into orbit. Millions literally witnessed it with their own eyes. Many countries, including their arch rivals, the Russians, tracked their flights the whole way to and from the moon. They filmed every minute of every mission in movies and stills. They brought back 382 kilograms of rocks for geologists to study all around the world, which they still study to this day. They left ongoing experiments on the surface, which were monitored for many years. You can see high-resolution images of the landing sites on the internet. It's pretty damn clear. Anyone who's got 2 neurons that are connected can work that one out. On the other hand, you've got a bunch of lay people who claim that the 400,000 intelligent and educated technical people, they're all liars and it's a big conspiracy and the whole world, including the Russians, bought into it. But these people themselves, they are so clever. They can see through it all. They've caught NASA out along with 400,000 people. They're all keeping a tight secret. But these people who say they didn't work, they are just so clever. They've worked it all out.
It's lunacy.
Yeah.
Very good.
Every time they open their mouth to point out perceived discrepancies, because they are just literally just that, because there are no discrepancies, it's just illogical nonsense that dribbles out of their mouth. It's insane. It's got no merit. You can shoot them down in nanoseconds, picoseconds. You can shoot them down. You can debunk them in no time. And usually it's attention-seeking behaviour of a 3-year-old. In fact, I know more 3-year-olds who don't go charging around with such attention-seeking behaviour. Or they've got a book or something to sell like that. And they're just quite frankly, trolls. So I say, look, there you go. Make up your mind. Yeah. So there we go. Yeah, that was good. And that was good. I think it was that Bart Siebel or someone said to him, and so he punched him and it went to court. And the judge threw it out because lack of evidence. Yeah, I thought that was great. Anyway, so next, Alistair, then I'll tell you about next week, next month.
The best answer to those idiots is just showing your rooster tails.
Right, yes. Yeah.
The surface of the moon is a mixture of talcum powder and pebbles and cobbles and boulders.
Yeah.
It all goes up, straight down, and perfect parabola.
Yeah.
That angle is only right for 1/6 gravity. You couldn't do that.
Yeah, exactly. Yeah, but they keep coming up, the cheapest. So next month, we've got a guest, John Burkett, who's coming to talk about what you didn't know about Apollo 11. Just all quirky little points, little personal points, technical points. That's one of his pet topics. So I'm going to be in Dunedin on the 4th of August. So he's kindly coming up and...
Take warm gear.
Sorry, what?
Take warm gear.
Take warm gear. Okay.
Yeah.
Right.
Cold in Dunedin.
Right. Okay.
Like the lunar surface.
Like the lunar surface at the South Lunar Pole. Cool, thank you very much. Anyway, so John's going to be talking about that, so it's going to be really neat to continue on from there. So, all good. All right, guys, thank you very, very much for your attention. Drive home safely. Thank you.